Start, please.
Alright, so this is the presentation for our final project, Smart Doorbell. The equipment is a BeagleBone Black, the camera, 2 Zigbee radios, laptop, a pair of USB to serial cable, and the software OpenCV libraries for taking the picture, triggering the camera, and for doing some processing of the image and converting it to serial and back to image. The goals are to trigger the camera from the radar, to obtain that image file on the BeagleBone Black in Python using the OpenCV library, establish a connection from the BeagleBone Black to the remote laptop over the 2 Zigbees, read the convert the image on the BeagleBone Black into a string, and then transfer it over the air with using the 2 Zigbees to the remote laptop. The 3 major pieces of equipment for this are the webcam, the Zigbee radios, and the BeagleBone Black. The block diagram is shown here as described in the original project proposal. We have a ultrasonic sensor like we've had in past assignments. The radar set to trigger under 40 centimeters proximity. The radar is connected to the embed microcontroller, which monitors the signal from the radar upon detecting a proximity event. When that happens, when the radar detects a proximity event, the microcontroller over a serial connection sends that flag to the BeagleBone Black. It actually sends range and azimuth in general, but right now we're not using any particular piece of that, just in the presence of the flag. Then the BeagleBone, on the BeagleBone Black, we have the Python script. The Python script monitors the serial port using threads in order to not interfere with the main loop. The threads operate in the background. And when the trigger is received, the script triggers the camera to take a picture, save that image file on the BeagleBone Black. Then the script also converts the image into a string, which is then written to the serial port and sent over a Zigbee radio. The first one on the left is the coordinator, and on the right we see the destination, the router, connected to the remote laptop. On the remote laptop we have another Python script which essentially receives the string over the serial connection, converts it back to an image, and then displays it. Here we have a flowchart of the steps. The radar is connected through to the microcontroller over a serial connection, and when a proximity event is detected, a flag is sent from the microcontroller to the BeagleBone Black, one of its serial ports, which is read by monitored by Python, and when something appears on the serial port and the if condition is checked positively, then the Python script causes the camera to take a picture, saves that picture locally, then the script picks it up, converts it to a string, and then writes the string to a serial port where the Zigbee coordinator is connected. Then on the other side, the router receives the string, the sequence of characters, and on the remote laptop, another Python script reads it, converts it to an image, and then uses a library function from the OpenCV to display that image. Here we have a snippet of the code to sort of give an idea about those the details of those steps. We start. We create a named window on the image. We have a function defined to get the image and return it. There is a piece where the first approximately 30 frames are thrown away because the camera is not settled yet. Then the image we want to keep is saved into camera capture, and it can be shown, although it is not essential, on the original system, the Linux, the Debian. Then there is a wait key, and waiting until a key is pressed. There is a wait key function there, a method. And then finally, we can get some information about that file if necessary, and the camera is deleted. This part of the Python code of the script shows how the image file saved from the camera is opened and processed with a function that encodes the binary file into a string, a long string, using a base 64 alphabet. And for illustration, it's also printed to show the string. And then the string, the file with the string is opened, and the string is decoded and written again to another file, a proper image file, which can be used to display the image finally on the remote laptop.
Okay. Now let's go for the actual setup. So the actual setup is these are the two Zigbees over here, and this is the radar. Let me just power on a little bit. Okay. So, Dumitru, why don't you give the actual demo? So come near to the radar and
so
take a
right now
pic.
I'm about a meter away.
Okay.
So now we're getting close.
So when Dumitru takes a picture, you can clearly see the camera is turned blue. Okay. It will be take picture, and the beagle bone and the Zigbee will send it to the terminal, to the router Zigbee, and where it will decode it. Now why don't you go back to the target PC and execute the code, please. Yep. This is where we get the packets, and magically
So the image is there,
image,
and we can see the string on the bottom console.
Yep.
It's much longer than displayed. It extends to the right a lot.
Yeah.
But that's basically the remote side where the string is received, converted back to an image file, and the image file is displayed. I guess we can show that the code.
Yeah. This is the code.
Which opens the file, creates the image, the proper image file, and then displays it with the image read method.
Okay. Thank you, Dumitru. It's fine.